This is homework problem 6.8, which is a shape composed of a W10 by 45 with a 12 by 1 plate on top of it. Now, the first thing that I like to do again is to place hash marks or tick marks locating the approximate centroid of each shape. That's just a visualization technique that helps me as I continue on with the problem. Next, we will split up the composite shape into the W10 and the plate. For the W10 section, we will refer to the steel tables that are located in the back of the book. For the W10, we will find out that it has an area of 13.3 square inches. From the origin all the way at the left-hand side of the bottom flange, we will have to go an X distance 4.01 inches to the middle, or the centroid, the Y centroidal axis of that shape. The flange width is a total of 8.02 inches, so splitting that in half you get an X distance of 4.01. A times X is as shown. The Y distance comes from using the depth of the W10 by 45 from the steel property tables. The depth of this shape is 10.1 inches. Half of that depth would get us to the centroid of this shape, which would be 5.05 inches. And then A times Y gives you the value as shown. Next is the plate. 12 by 1 is of course 12 square inches. Again, if we assume that the plate is centered on top of the W section, then we would have to travel the same X distance, 4.01 inches, and the product of A times X is as shown. The Y distance from the origin to get to the centroid of the plate would have to go the whole depth of the W10 shape, which is 10.1 inches, plus half of the 1 inch thickness, another half inch. So that Y distance is 10.6 inches. A times Y is as shown. Summing up the area column, we get 25.3 square inches. Summing up the AX column, we get 101.45. And summing up the AY column, we get 194.37. Applying these values to the X bar and Y bar formulas, we find that X bar is 4.01 inches and Y bar is 7.68 inches.